helping us. Leonidas in Zoom, do you hear us?
I am going to present the Netapps developed by Yogoko. So we are developing the Netapp 2 and defining and developing the Netapp 2 and Netapp 3. Netapp 2 is about virtual roadside unit Netapp, and Netapp 3 is cooperative central ITS station Netapp. I am going to give some indication first about about what is cooperative ITS communications. A few words on Yogoko as well. So in order to explain the context. So Yogoko is a French company working on cooperative ITS. So we develop a software stack which implements standards. Cooperative ITS is a set of standards for smart city, for safe mobility and sustainable mobility. So it's standards to allow vehicles, road users such as pedestrians, cyclists, infrastructure managers, road operator, and so on to communicate together. So and using a common set of standards to be implemented by all stakeholders. So we at Yogoko, for example, we provide equipments to be integrated into vehicles. We provide cloud services. We provide test tools to support cooperative ITS communications. We deploy software all around Europe and all around the world. So there are different set of standards in Europe, in US, and in other regions. And we support car manufacturers, road and smart city operators, and other stakeholders into their adoption of these standards. So I'm going to show a couple of use cases related to cooperative ITS. So the most well-known services, the first day one services were about driver awareness. So it's infotainment, so showing to the driver in a very dynamic way the real state on the road. I mean the real and up to date and real time status on the road. So what are there accidents? Are there roadworks? And all these informations are provided by and broadcasted in real time by road operators, including vehicles, moving vehicles of road operators, which make it very dynamic. And also the information is tagged and secured, so it's authenticated. There's other use cases such as traffic light maneuver. So traffic lights providing their status, their current state, and which are the possible lines between in the intersection. There are use cases about protection of vulnerable users. So in that case, we want to avoid collisions between pedestrians or cyclists and vehicles. There are many more use cases, so such as stalling assist, platooning, and so on. There are some use cases which are very, let's say, time critical and very real time. So when we speak about, for example, emergency brake light or platooning, you need a very time critical they are very time critical use cases, but there are also use cases which are more let's say wider, with a wider range. So we have to deal with both with both principles of operations. So there is a wide diversity of users, a wide diversity of use cases. Initially, these communications were addressed with dedicated short-range communication. So it is initially based on a radio. In Europe, it's ITSG5 based on Wi-Fi, but we are now doing the same also via the cloud communication, so via cellular communication, and we are working to adapt this and to integrate it into the 5G infrastructure, so as we may provide the same, implement the same standards in the scope of the 5G infrastructure. So I am going to present our Netapps then. So I am starting with the Netapp 3, and then I will go to Netapp 2. The Netapp 3 is more wider. So the idea is to cover a wide area. So it's deployed in the core infrastructure, covering a wide area. The idea is to avoid having to set up and to deploy too much hardware, too much infrastructure. So by providing a cloud platform, we allow to forward cooperative ITS messages from and to connected vehicles and infrastructure which are connected using cellular communications, classical cellular communications, so such as 3G, 4G, 5G, and so on. We allow to interconnect with external servers. So it may be over Netapps, but it can be also outside of the 5G infrastructure, public or private road operator servers. It's also the role is also to trigger cooperative ITS use cases over a wide area. So it may be service advertisement of a region. It may be informing about traffic conditions, weather conditions, and so on, which are which are more related to a wide area and not necessarily to a specific zone. So that's it. Just as an example, the idea would be, for example, also to cover the need to connect personal ITS stations. So, for example, as I said, cyclists or pedestrians, we would very unlikely have a dedicated, chipset, radio chipset supporting this radio communication. So, using their 5G connectivity, they would be able to benefit from these services. Without such an infrastructure, they could hardly have access to such informations and be covered by these protections. So about the virtual RSU, this is more a local, dedicated to a local area and a reduce, a smaller area. So it is meant to be deployed in the edge infrastructure in the MEC. So the idea is that by being deployed on the MEC, we could support communications about over short-range communications or side-link radios. So it may be 822.11p. So it's another name of ITSG5. It can be 5G device to device, or it can be CV2X, cellular V2X, which is a side-link communication which allow to a direct communication between two vehicles over, using 3GPP standards. So we can both provide this and also the support for long-range radios, so classical cellular 3G, 4G, 5G in the same unit. The idea is also to optimize data exchange between the edge and the core Netapp. So in case we have a lot of vehicles or a lot of events occurring in the same zone, we would likely be willing to address this locally. So to deploy such a node locally in order to avoid a too high traffic on the cloud. And also triggering cooperative ITS use cases covering a local area. So in contrary to the cloud, in that case, we would cover a more reduced area around the radio coverage. And finally, also, it would allow us to trigger cooperative ITS use cases which require specifically short-range and or time-critical communication. So, for example, when you speak about platooning or collision warning, when you are at a pre-crash time, so you need a very time-critical communications. So in that case, the more the processing is near your vehicle, the less time it will take. So it's also important to say that there are these different types of communications and different types of time criticality in the cooperative ITS standards. So that's it. The idea is to virtualize these roadside ITS stations, which are for now real one, to virtualize it into the 5G infrastructure to reduce hardware costs while ensuring time critical communications. So about architecture, globally, you have the central IT station there. You have the virtual RSUs, which are connected with short-range communications or long-range, classical cellular communications, which can work together, which can be controlled also, so as we may dynamically deploy a MEC where we need to, according to use cases we want to address, according to the traffic conditions. And we may also connect legacy, let's say legacy roadside units and so on, so as we can still make it cooperative. So it is the core thing into a cooperative ITS standard. The more nodes connected, the more there will be value in this data. So let's go a bit technical about NSD, VNF, and Nest. Maybe not, a few words about what we are designing there. About the virtual RSU, so the MEC one. So we about some design choice we made. For example, about dependency to the 5G system, we will depend on the CV2X radio or any other silent or short-range communication. So in that case, the RSU will be able to exploit and use the radio communications provided by at the base station level. In terms of dependencies, both cloud and edge depends one on the other. In terms, for instance, of QoS, we will we will depend on I mean, a limited throughput per equipment, but with a high time criticality, because we are using road safety services, so we need a slice quality parameters for time critical services. And about velocity, for example, we are targeting vehicular velocities, so from 10 kilometers per hour to 200 kilometers per hour. There are also pedestrians and cyclists, which should be taken into account, but it's not much an issue there. About the cooperative ITS, or the central ITS station in the cloud. So the same about interoperation between cloud and edge. Both depend on the other. About internet access, we will expect that we need to communicate with third-party providers, data providers, or other central ITS stations, other operators also. So we need this access, and also we have a higher dependency in terms of let's say hardware requirements, because we need to cover a high number of station and object, but it is also highly dependent on the number of station and object we are needing to address. So it may need to be tuned per infrastructure. So that's it. Do you have questions? I hope I was clear.
There was just one question in the chat earlier. In slide 4, you showed the capability of interconnecting miscellaneous nodes via the cloud. Why not leveraging also peer connections, or does the cloud offer more benefits? This was the question.
About I'm sorry, peer connections. I'm sorry, I didn't understand the question.
So on slide 4.
Yeah, I'm going back.
Show the capability of interconnecting miscellaneous nodes via the cloud.
Yeah.
Why not leveraging also peer connections? Yes. Or
Peer
does the cloud peer?
Okay, okay. Between cloud. Between several cloud services. Is it that? Because it is also the principle. The principle is to also communicate between several cloud providers, and also there are national ITS stations, central ITS stations, which are going to provide, let's say, a central node over a country to route messages between different providers, infrastructure, and so on. So it is definitely going to be a federation of clouds. So we will interconnect in a federation with other service providers, because it is the only way to make interoperate car vendor 1 with a car vendor 2. Without that, you cannot have an interoperability. Did I reply the question?
Yes, you have a thank you in the chat as well. Thank you.